We're going to be finding the derivative of a to the x times natural log of sine of x. And whenever we have a problem like this, when there is an element called a, almost always that is a constant, or in other words, a number. It's just any old number, we don't know what it is. All right, so the first thing we're going to notice is that there are two parts to our equation here. And so we kind of have this a of x here, and then we have this natural log of sine of x, and these two are multiplied together. So that tells us that we want to use a product rule, and that is in fact where we are going to go to do that. That means that we need the derivative of the first bit times the second, leaving the second alone, plus leave the first alone, derivative of the second. To do that, we're going to need the derivative of both sides, first and second bits. So we're going to do that as an aside, and then we're going to piece everything together to make it look really nice. All right, so let's start off with y is equal to a of the x. We're just going to assume we're looking at just that first part of our equation, and we want to know what does the derivative of that look like. When we have x in an exponent, we're not using a bring your exponent down and subtract one. That is a problem a lot of students make. And instead, when an x is in the exponent, what you always want to remember is to use the natural log when you're working with it. This is always the way to go when you have an x in the exponent and you're trying to take the derivative. The reason for that is we can then bring x down out front, because whenever we have any value, natural log of a to the b is always equal to b times natural log of a. You can always bring that exponent down out front. That is a wonderful thing to have, which means we're looking at natural log of y is equal to the x times the natural log of a. All right, that looks a lot better. Let's do a couple more things here. So I'm going to just write that out again. We got natural log of y is equal to x times the natural log of a. We are trying to take the derivative of this. So we're going to take the derivative with respect to x, and we're going to use implicit differentiation here. So the derivative of natural log of anything is 1 over that thing, so 1 over y. And then we're going to times that by the derivative of y prime. On the right-hand side of our equation, the derivative of x times a constant is just going to be that constant. Remember that natural log of a, because a is just some number, is just natural log of a is some number as well. All right, to solve for y prime, we're going to take this y here and move it over to the right-hand side. So we're going to multiply both sides by y. This is going to give us y prime is equal to y times the natural log of a. We know y is equal to a to the x, so we can just punch that back in. And now we know the first part of our situation here. We know the derivative of a to the x is going to be a to the x natural log of a. All right, so that's part one that we are done with. Now remember, there are two parts to this that we're working with. So let's look at that second part of that equation. The second part of our equation was natural log of sine of x. Right, when we take the derivative of that, remember we have an inside bit here, our sine of x. So our y prime, we are going to do the chain rule. So we have 1 over the inside bit times the derivative of an inside bit. So times the derivative of sine of x. So our y prime is equal to 1 over sine of x times cosine of x. In other words, cosine of x over sine of x. If you want to be super fancy, you can rewrite this as cotangent of x. Personally, I don't believe that's worth the brain power to memorize those things. So I would just keep on writing as cosine over sine. So there's the second part of our equation that we wanted to know the derivative of. Let's go back to our original function. So we started off with y is equal to a to the x times the natural log of sine of x. And we wanted to take the derivative of that. So we knew we were going to have to take d dx of ax times the natural log of sine of x plus, leave our first bit alone, times the derivative of natural log of sine of x. All right, and we also know our derivative for a to the x is a to the x times natural log of a, and then we just copy paste the second part of that right there, plus a to the x times the derivative. I'm going to keep on writing this as cosine of x over sine of x. All right, so there is our derivative of our function using some nice tools that we're working with. Thank you so much for listening.